Hi everyone, this is Mrs. Jackson. This is Chapter 1, Section 3, Part 2, and in this video we're going to talk about how to describe an absolute value function as a piecewise function because it actually has two pieces here that make up that V. So we can break that up into those pieces and equally describe it just as if we would with an absolute value function. Okay, so let's zoom in here on this graph. First of all, we know that the absolute value parent function is y equals the absolute value of x. Now in this case, we have a couple of transformations going on. First of all, we have a translation to the right by 1 unit. And we also have some kind of either, depending on how you look at it, either vertical stretch or horizontal compression, because you can see here that the slope of the two sides is not 1/1. So we do have some kind of compression or stretch. Okay, so first let's tackle the translation piece. If I want to translate 1 to the right, recall that that means I'm going to subtract that 1 unit from my input variable. So going right, subtract. Going left, add. Okay, now how do we deal with this stretch or compression? I'm going to view it as horizontal compression. Okay, and we got to choose one or the other. I'm going to view it as horizontal compression, meaning it's getting skinnier in the horizontal direction. Getting skinnier in the horizontal direction means that our compression factor A is going to be greater than 1. And in this case, for an absolute value function, that A is actually going to be the slope. So let's take a look at what that slope is. On the right side, we've got a rise of 3 and a run of 1. And of course, it's symmetrical. So on the left side, we've got a rise of -3 and a run of 1. So I'm going to go ahead and put my factor A in there. And what's important here is that I'm multiplying that x minus 1. When you are writing that translation piece, it's got to be written as what is happening directly to the input variable. So this 3 is on the outside of this expression, x minus 1. And I could just finish up and maybe write it in function form here. F of x equals the absolute value of 3, x minus 1. Okay, now let's look at it as two linear pieces, two linear functions. I'm going to put that in maybe red here. So over on this piece, we've got a linear function, y equals mx plus b. And as we said on the left, the slope is a -3/1, and its y-intercept is +3 right here. And on this side, we have y equals mx plus b, and that m is going to be the +3. And you can solve for that b if you want to, or you could just keep the trend going. If I go down 3 here and over 1, hopefully you can see we're going to land at -3. So there's definitely a relationship here. Let me point that out. Each of these pieces, because of the symmetry, over here that slope is -3, over here it's +3, over here our y-intercept is +3, and over here it's going to be -3. So that's forming the symmetry. Okay, so when we bring all of this together and describe this in pieces as a piecewise function, we're going to say that f of x equals, remember I said that the symbol for the set of is always braces? So really we have a set of functions. So I'm going to use some braces here, and I'm going to write my function in the two different pieces. We have on the left side -3x plus 3. And on the right side, we have +3x minus 3. So I've got that my function f of x equals the set of these two functions, and they have a restricted domain. The only thing that we have to decide, however, is what is this point here, the vertex. So we got to decide where are we going to put that vertex. Are we going to put it in the left piece or are we going to put it in the right piece? And it's really completely up to you. You just can't put it in both. So we're going to, I think I'm going to put it in the left piece. So in the left piece, we've got negative 3x plus 3, and that's for all values of domain that are less than or equal to positive 1. In other words, it starts at positive 1 as our maximum, and our minimum is all the way down at negative infinity because it's non-ending, non-terminating. And the right piece is going to begin right as you move to the right of 1. So it's going to be greater than 1. And then it goes on forever up to positive infinity. And then just to finish here, this is the same thing as f of x equals our absolute value function. So I'm going to put the 3 in here, x minus 1. And so the point is both of these completely describe that absolute value function on the graph. Now, if you wanted to rewrite this a little bit and distribute that 3 inside, you can, as long as you don't become confused here about the translation. So you could do this and distribute that 3. Just recognizing, however, that if you went to graph this, that is not a translation to the right of 3 units. So this 3 had to be taken out using the distributive property if you want to see exactly what the translation piece is. Okay, let's start from the other direction now. We've got an equation, a rule here. Now let's see if we can write this, first of all, as a piecewise function. And also let's try to graph this just for practice. So here we've got 2x minus 3 on the inside. That's going to be 2 linear functions, the right and the left side of the v, and they're going to be opposites of each other. So I can rewrite this as f of x equals the set of, I can take the right side, 2x minus 3, and the left side of the piece is going to have its opposite slope because they are symmetrical, and it's going to have the opposite y-intercept. Both of those are limited by domain, and let's see, where is that vertex? Where is that vertex? Because we're going to need that to figure out how to describe the domain in each of these pieces. So what determines the vertex? What determines the vertex is that translation. So I have to see exactly the shift on my input variable. And with that compression here, this 2, I can't right now see exactly what's happening to x. So I have to rewrite this in an equivalent form here. So I'm going to do that. F of x equals, I'm going to have to factor out that 2 from the x term. And when I do that, I'm going to have to rewrite this term here as 3 halves. And in doing so, if I were to distribute that 2 back here, I would end up with 2x minus 3 halves times 2, which is minus 3. So in doing this here, I can see exactly what my translation is now. If I'm subtracting 3.5, or we could call that, not 3.5, if I'm subtracting 3 halves, we can also call that 1.5. So I can see subtracting means I'm going to the right 3 halves, or 1.5 units. So that's going to tell me exactly what my vertex is going to be here. So I'm going to go back up here to my piecewise function. And again, I have to decide, where is that vertex point? Is it going to be in the left piece, or is it going to be described in the right piece? I usually put it in the left. I don't know. That's neither, that doesn't mean that's the only correct answer. But I'm going to say that our, I actually put the right piece on the top. So I'm going to say my left piece is going to be for all values of x less than or equal to 1.5, or you could write that as 3 halves. And our right piece is going to be all values of x greater than 1.5. All right, let's see if we can try to sketch this out a little bit. I'm going to try to draw some axes here. And I guess I'll do this. And I will do this. So I've got just a quick little sketch here. It's not great. So let's just put some coordinates on here, or some axes. I'm going to say this is 1, 2, 3, etc. I'll just keep this going. All right, so it's not great, but we can see that our translation is going to be to 1.5. That's going to be my vertex. And my slope is actually going to be rise of 2, run of 1. So I'm going to rise 2 here from this point, and I'm going to run 1. So my next point is going to be somewhere like here. And I'm going to rise 2 and run 1. And so you can kind of see here our absolute value sketch. Okay, so to recap, in this video, we described an absolute value function with an absolute value function, as well as describing the left and right pieces of the V using a piecewise function. Hope this helps.